Hello, chemists! Welcome to our GSK Science in the Summer Color Chemist Research Team. I'm David Wrigley from the Franklin Institute, and I'm so glad you're joining us. You're going to become a color chemist and help our research team create a new paint color. But first, you might be wondering, what does it mean to be a color chemist? Here is a color chemist at work. What do you see in this picture? What do you think the person is doing? Good observations. You probably noticed that she is holding some sort of tool. Maybe it looks like she's adding something to a container or mixing it. You might also have noticed a tube of colored liquid in a rack in front of her. So, what does this tell us about what a color chemist does? That's right. Color chemists use tools and chemicals to make colors. They create the pigments and dyes that give color to all the things people make and buy, like the fabric of your clothes, the plastic of your toys, the paint on houses and cars. To create pigments or dyes, we, as color chemists, are going to have to pay close attention to the different properties or qualities of the materials we use and how they change. Color is an important property for us to pay attention to, of course, but we will also have to notice other properties, like whether a material is solid or liquid. Another property that is pretty important for color chemists, but hard to see, is acidity. Acidity is measured using something called the pH scale. Things that are very acidic are on the red side of this scale. Vinegar and lemon juice and many other things that taste sour are acidic. Things that are on the opposite of acidic are called basic, and they are on the purple side of the scale. Baking soda and a lot of soaps and detergents are basic. Things that are right in the middle, like plain water, are not acidic or basic. They are neutral. Let's see why this is important for creating colors. I have a strip of paper here that has a pigment in it to give it color. What color does it look like to you? Sort of light orange? I also have 2 cups of water here that I've added some chemicals to. This one I've made more acidic, and this one I've made more basic. Let's dip the paper into the acidic one. What do you notice? The color of the pigment in the paper changed to red. What do you think will happen if I dip the other end into the basic liquid? Hey, was it what you predicted? It changed the paper to purple. So this shows us that some pigments can change their color when exposed to an acid or a base. So as you work on your research, keep an eye out for how acidity might affect the colors you create. Now you're ready for the problem our team is researching. Our team works for an art supply company that makes paints and inks for artists. The company has decided to make a set of watercolor paints called Nature's Inks, which are all made from things found in nature. Our exploration team has found 2 natural pigments that they think might work for making paints. The first is the flower of a plant called the butterfly pea. The second is the dried up leftover shell of a tiny insect called a cochineal. Say that one with me. Cochineal. We need your help researching ways to make paint from these materials, and then ways to change the paint to make as many different colors for the paint set as possible using your science materials. Here's your job. Use the GSK Science in the Summer Color Chemist Activity Guide to follow these steps. First, do some research to find out what color each natural material makes. Then, You'll need to test some ways to change the materials and see how many different colors you can make. Your science materials include all the tools you'll need, along with some samples of the two natural materials and some chemicals for testing. Write down all of your observations and results in your lab notebooks so that you can share them back with the team when we have our live lab meeting together soon. We'll need your recommendations to share with the art supply company about how to create paints from these materials. Are you ready to get started on your research? Great. Thanks for your help, chemists. The rest of the team will be waiting to see what you discover.